This is Daniel, and you are going to get coded. This is the part 2 of the video that I made for dictionaries collection or class, and you can see that video. I'm gonna put that in the description down below, so you can have the link right there. But this is the exact same place where I left the last time that I recorded, so for the part 1 of this series on dictionaries. And I saw a little bit of that first video myself. I tried to watch it a little bit, and if I am too shy, or I don't know, I spoke a little bit slower or not as high, please forgive me, because I've not done some videos in quite a while right now. But I'm trying to get back on track and make videos and just get into the mood again of like recording videos. I've not recorded myself in like 2 years, I think. So please bear with me, okay? As I said, this is exactly the same place where we left the last time, so we can just continue on. So what I want to do is the unique keys. As I said in the first video, actually, a dictionary contains specific, or rather unique keys, so you cannot repeat the keys that you wrote in the dictionary. Let's see what I wrote in the tutorial. Now let's try adding more grapes to our store. Maybe we might have forgotten that we just initialized our dictionary with grapes already, and we could do something like this. So you can see here on line 14 that we already have grapes inside our dictionary. And this grapes, the grape key, has a value of 14.8. Let's try to do this again. So after our for each, I'm gonna use that one there, or let's try to do it before. Before this, we can say store.add. We are going to add grape again, and let's see what happens. What happens? If you remember from my previous video, you would know that this is going to throw an error because this grape key already exists. But let's see it with our own eyes right now. Let it crash right now. And you can see that it threw an exception. So unhandled exception. The argument exception, an item with the same key has already been added, and the key is called grape. So we already have the grape. And this could happen sometimes because you might have forgotten, as I said in the tutorial, or you might get this from another source, from an API, from a database, from anywhere basically. So it's not a safe operation to do directly. It's not safe to just add stuff into a dictionary, because you know that one specific criteria of the dictionary itself is the unique keys. So you need to have that in your mind whenever you are dealing with dictionaries. You need to make sure that, oh, I need to double check before I'm adding some items inside, because I don't know. I don't know if they exist already. So let's try to close this. Let's try to stop this, because this already, the exception was thrown. We cannot do anything right now. And you can see that I wrote here the argument exception. So this is the exception. This is the actual exception that you get. Let's read. The keys must be unique, and unique with Q-U-E. Sorry for the misspelling. If you think about it, this is why I didn't choose to use quantity as my key, because we might have similar quantities for the same fruit types. And this is why I want to make these videos. This is why it's so important for me to like go through all of these things one by one to make you understand why I chose to have the fruit type as the key and not the quantity. Because the quantity can be the same. For example, we might have 4.5 kilograms of peaches, and then we might have 4.5 kilograms of lemons. So this is not unique. The quantity inside our inventory or inside our store is not going to be unique. This can be the same for all of them, so it cannot be used as a key. So whenever you think about that, okay, I want a store. Let me think. I want a store. I have some fruits. I have some quantity. Let me see which one is the key. So this is like the thinking pattern that you want to go through. So which one is the key? Oh, is the fruit type, because they are unique. And it makes sense for me to have that as unique, because I can just put the quantity and I can just get that for each fruit type I want. So for example, I can ask later on, I want lemons. How many lemons do I have? How many kilograms of lemons do I have? Oh, you have 10. you know? So this is the thinking pattern that has to go inside your brain. Think first, which one is the key, and then ask yourself, can this key be unique? Is there a possibility inside my collection, inside my database, inside my, I don't know, my inventory, that there might be a similar key, the same key, items with which are not distinct? And then you can choose your key. If for some odd reason our store had like the same fruit types, like peaches and like some like, it just doesn't make sense, because this is like exactly how it's supposed to be for the store. But if it was like that, we could not have used it. We could just have used I don't know, numbers, or we could have just created an enum or something like that. But again, this works right now. The best practice is to check whether or not the key exists in the dictionary before trying to add it. Let's see how this is done. So first, we keep an eye, or the line before. I don't know what I wrote here. Let's move on. But we need to check if the key is not present in the dictionary with the contains key method. You can see this one over here. We need to use an if statement, and we need to check if the key itself is contained in the dictionary. If it's not contained, we can just add it. So this is not a safe operation. This line 18 is not a safe operation. We need to surround it with an if statement. So if store, or let's try to write it one by one, store.contains key. If store.contains key contains grape. So let me know if the store contains key. If it contains, then we do some stuff here. Else, we do some stuff here. And the thing that we want to do is, sorry about that, is the adding of the grape. The reason why you can see the exclamation point here is that I don't want to have an empty clause. This is perfectly fine. This code works, this code compiles, you don't need to do anything else. You can have empty clauses like this, but it just doesn't make sense, you know? So you need to negate the expression. The expression is this one. So you need to say not. You need to negate it. And there are two ways of doing this. You can say false if this is false, or you can just read this one, contains key, and you can say if it doesn't contain key. If it doesn't contain the grape key, then you can do this one over here. Okay, so this is like the reverse. Also, if you remember from our previous video, the part 1 of dictionaries, we are using Visual Studio. And in Visual Studio, being an IDE, has some features, has IntelliSense, has some type inference for your C# code. So let's try to undo what we just have done with the negation. And let me try to just click on the if statement and then control dot. So control dot is your friend for calling the IntelliSense. The IntelliSense is your friend, and the control dot is you calling it. You can see that it has invert if, so you can invert the actual if statement, which is so fun because you don't have to do anything yourself. You can just press enter, and this is going to know how to actually negate this. So you can just put the exclamation mark before the expression in the if statement, and we can just remove the else. So right now, we are testing. We are checking if the key already exists. If it doesn't exist, then add it. And if we run our code right now, you can see that our code works. How does it work? It still has the 14.8 grapes inside our store. And why does it have that? Because the grapes that we see on the line 20 has not been called, because the store already contains the grape. So it doesn't go into line 20 because it doesn't contain anymore, because it contains it already. It doesn't have to go on line 20. And this is the reason why we don't have 7, we have 18.8 instead. Okay? let's try to close it and let's continue our tutorial. Then on the else branch, we can increase the quantity of grapes because we know that we have them in the store. So because we already have grapes in the store, you can utilize that else to increase the grapes. So we don't need to add the item. We can just increase the value of the item. So inside our if, or rather in our if structure, we can add the else branch. Okay, so proper terminology, because you need to know also how to like express the things that you write in code. And you can see that we have some things over here. So we are calling, or we are trying to get the index of that store. We are dealing with dictionaries. So we can have var value. This is the value that we are going to retrieve from dictionary. And this is the power of dictionaries. You can just say the name of the dictionary, then you can use the square brackets. And then you can specify what do you want? What item do you want? And here you specify the key. Oh, I want the grape, because I know based on the line 18 that you, the store, the dictionary, already have the grape. So I can safely do this run right now. It's not unsafe anymore because my logic has checked that before. And then I can just get the value. If you hover over var, you can see that this is a double. Also, you can change it. Again, control dot, you can see double. And I like it, this one right now, because you don't have to like hover over var to like see which type of value this is. You can just use it like this. And this is my preferred way of writing C# code. I like this. This is more readable, and you should consider writing it like this, as I do. So double value equals store and grape. Okay? And then the value, this value that we got from our store, I want to increase it with this 7. This is the new value that I want to add inside. So this is going to be plus equals 7. And this operation here, this operator, increases. This is the increasing operator, increases the value with 7. And this is the same as if you were to write value plus 7. So the new value is going to hold the previous value, but with the added quantity into 1. But we are too lazy as programmers to write something like this, and it's easier to read the increment operator, as you can see here. So plus equals. This is why we do it like this. But right now we have increased the value. So we got the value, we have increased it, and now I have to put it back because it's not in the store. It's not in the store. The store contains the old value because we have just retrieved it, we changed it, but we didn't do anything to that. We didn't even put it back inside our store. The store is not aware of what happened to this value because the store just gave it to us. Doesn't know. So it doesn't have a reference because this is a double. Okay, this is a number. It doesn't have a reference. We need to put it back. So we need to use the same item. So this store, square brackets, and grape, we need to use the same item to actually put in the value. So this item is going to contain this new incremented value with 7. Again, for some people this code might seem easy to understand, but for beginners it's a lot going on and a lot of mindset, a lot of principles, a lot of whys that you need to know before you write something like this. This is why I'm trying to go one by one to just show you how you can create a new dictionary, how you can add some values in a descriptive, easy, and understandable way, how you can check to not get errors whenever you want to add a new value, and how you can actually utilize the dictionary to increase the values you have inside. So this is the retrieval of the value inside your dictionary. And this is the incrementation. So you increment, or the incrementing of that specific value. and then you put it back. So this is the update. So you update that specific item. So the item is the dictionary and the key, and then you pass in equals the value, because this points to a specific value. Okay, and this works. Let's see if this works. I don't know if this works. Maybe you have some errors. You never know until you see it in front of your eyes. You never know. So 21.8, yes, because we had 14.8 and then we added 7, so 21.8. Yeah, math works. This is how it should be. Okay, and now we have 21.8 kilograms of grapes. Let's try to refactor our code. Refactoring, before we jump into the tutorial that I have on the left, refactoring means to make your code easier to understand. You just clear your code. It's just like whenever you write an essay for English, for example. You just want to go through it again, or you go through it many times. The same thing goes with refactoring. You go through it many times to actually see the wording which you used. If you want to change some words to put some synonyms instead, or if you made some grammatical errors, or if you you tweak the text to make it more readable, more understandable, and to actually make sure that it expresses what you want it to express. So this is like the perfect analogy. So English essays and the refactoring coding. So let's refactor, because we use the string grape way too many times, and 7 for quantity as well. So you can see that inside this this if structure, this if statement, we have used grape 4 times. Grape, 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 grape. If we wanted to do this for lemon, we needed to change lemon for each instance, for each occurrence of this. And this is so much work. And it's not just a lot of work. This could have been just a long file, 1,000 lines of code. Imagine doing this for all of them. And also the last reason, the third reason, whenever you see strings like this just floating around your code, they are not the safest, because they are easy to misspell. They're easy to think that they are something else. Maybe we wrote lemons and not lemon, or I thought we wrote, it's just a lot of confusion. You don't know, it's just not a good way of writing code. This is not a refactored code. This is not a clear code. This has some issues. So you can see that I actually extracted, this is the term, extracted the type into a variable, and then extracted the quantity that we want to increase into a variable. So let's do this. I'm gonna undo the changes that I have just made, putting back to grape, and then I can just say grape type equals grape. And right now I can use this grape type variable to replace, sorry, let me try to copy that again, Control C and then Control V, replacing all of these instances. And you can see right now, if I click on grape type, you can see that Visual Studio actually tells me and shows me all the instances, all the occurrences. And when I want to change it, I can just refactor the name. So right click on that one and then rename, or F2, and you can say lemon type and then apply, and then we can just say lemon. And right now we can just change it here, and this is going to be reflected all over. This is one way of doing it, but because we have an IDE, we have Visual Studio, you can actually do something like this. You hover over this, or you select it, you select the value, you select like the magical number or text. This works for strings as well. You can say control dot, and then you can say introduce constant or local constant for 7. I'm going to introduce a local constant for 7. No, this is the local constant for the if. I'm not going to do that. Control Z, undo. I'm going to create not a local constant, but a constant for 7. Where is my constant? The value is going to be grape quantity. And you can see that it put it here. So it put it as a private constant grape quantity. Whenever you use the IDE, it's going to create private consts. It's going to put them outside. This one is inside our main method. You can see the main method. This is outside. You can put it either way. I don't know if I like this one right now. So the IntelliSense prompted me or suggested this to be the way to go. This could work because in a class, you want special numbers to reside at the top of the class as private constants, as private members, because they are going to be used throughout your code. But because this is going to be used just inside the main, I would not want to do something like this. So let's try to undo. Let's keep it 7 there. And let's try to do it manually. Grape. And this is good because I showed you like what happens if you use the IDE and what's the difference. Because I know that it's going to be used only inside this specific method, the main method, I can just declare it as a local variable inside that one. And I can just replace these. So right now, our code does the exact same thing, and that's the point of refactoring. Refactoring means you change your code, but you don't change the logic. So you just change the structure, the syntax, the wording. You introduce some local variables. You change the name of the method. You change the name of the class. So these are the refactorings that you could do. You can invert an if statement. That is a refactoring because the code remains the same. You don't change the logic. And when you are going to write some unit tests in the future, you are going to actually see refactoring as the last step inside your approach to coding. And in order to make sure, actually in the future, that your tests work, when you do refactoring, they should work as well. So refactoring should not change the logic. So right now our code looks the same as to the left side. So let's add some more lemons. Add, and we have to do the same thing. This is what we have to do. So right now we have grapes, but what happens when we want to add lemons? We have to do this whole thing again. Like imagine like doing this again, like writing this for lemons. And also, oh, I forgot to refactor it back again. F2 grape type, because I was explaining the refactoring. So we are doing grapes right now. Okay, grape. This code here is written to add a new grape. But imagine if we want to add lemons, we have to write this all over again. So copy and paste, and we have to change this one to lemon type, and then we have lemon. And imagine like doing this, like this is just not going to, and then this one to lemon, like pfft. And this is where we need to use methods. You have a piece of code that you want to reuse, just put it inside a method. Just put it inside a method and parameterize it. That's the fancy way of just saying look for what's dynamic, meaning these two are dynamic. This is the reason why we refactored it previously. So we refactored it previously. You saw that these things change, meaning they are dynamic. They change inside your code. We put them here. And right now, this is so beautiful because these are actually our parameters, and this is actually our method. So we can also refactor this as a method. It's already done. So let's try to read what I wrote here. This is where you can extract a function which does this. It adds quantity of fruits. So we can add a new line to add fruit quantity and name it just like that. So as I said, I'm going to undo because we are not going to repeat our code. And here is so hot. It's such a warm weather here in Denmark. Like it's just so warm. I'm just dying. And also I have like huge lights so that you can see me. And it's just like, oh my God, I'm just like, but I will survive. So let's try to create a new method. but I want to use the IntelliSense. This is why I have these steps over here. So add a new line to add fruit quantity and name it just like that. So you can actually use the name of the method before you create it, because we want to use the IDE, we want to use Visual Studio to do that for us. Add fruit quantity, store where we want, grape type what we want, and then grape quantity how much we want. And this is going to be underneath our two variables. The grape type is going to be passed here, the grape quantity is going to be passed here, and this is going to add fruit quantity to our store. And then we can say control dot, and this is going to create a new method. But this is going to create it like this, store, and then if we scroll to the right, you can see grape type and grape quantity. This is going to just be for this specific, because the IntelliSense doesn't know, oh, this is a type and this is a quantity. So if we say enter, you are going to see, oh, right now we have a method that has store and grape types and grape quantity. So it has these two things. But this is generalizing. We want to generalize it to this, because right now we don't depend on grapes. We depend on, let me try to refactor it like this so you can see it better. We do something like this. We have the store, the type, and the quantity. So now is a general method that can add fruit quantity. It can add grapes and lemons and all of that. So instead of throw new implementation, not implemented exception, we can put in our code. So let's try to get our code from here, our if statement, and we put it here. And instead of grape type, we have the fruit type. Let's try to say fruit type to be like more specific. Fruit type, everywhere, fruit type, and then the quantity. And you can see right now this knows how to add a new fruit to our store. And we can extract the checking functionality and moving it to our new function. So this function or method is going to have our checking functionality. And then we can add lemons as well. So this is like the whole point. Also, you can see that right now we have not used these because we pass them as arguments. So instead of doing this, we can say control dot, and you can use inline temporary variable. And this is going to inline it like this. It's going to put it back. Let me undo. Let me show it again. Control dot, inline temporary variable is going to put it here. And the grape quantity, 7 here, is going to put 7 back here. So let's try control dot, inline temporary variable. This is going to put 7 here. So right now it's so much easier. So we pass in the dynamic content, the dynamic logic from our method as arguments, and then the logic is going to remain the same. So this is actually how to generalize a method. So this is now generic for any fruit type, and is going to be callable by any. So we can just say add fruit, store, lemon, and then 3, and this is going to add lemons. Then we can do this for grapes and for other things, so we don't have to repeat ourselves. This is so fun. Let's try to read our tips before we run the code to actually see if this works. Notice that we didn't have to create separate variables again. We could though, but now we pass them as arguments to the function or to the method, and we don't need to repeat ourselves. So we just pass them once as arguments, and we don't need to repeat ourselves. And then functions, because we might use certain functionality in the future, we have functions which helps us reuse our code multiple times. So we have a piece of code, a piece of logic, and this is going to be reused and reused every single time that we want, by just calling it as a method. Okay, let's try to run this and see the quantities. So right now we have 13 kilograms of lemons, indeed, so we have 10 here and 3 here, and then we have grapes more as we had previously because we were adding 7 before, and peaches remain the same because we have not changed anything, so we have not added any quantity or increased the quantity of our peaches. Lovely. Let's try the last step, extension methods. You know me, that I want to push you guys a little bit. What about being able to call this method add fruit like this? Store.add fruit quantity, and then we pass it. Let me show you. Let me just show you in the code. So right now we have a store dictionary, but we have an add fruit quantity method that is defined here. What if, and we pass it as an argument, we pass the store as an argument, but we know that this add fruit quantity belongs to the store. It belongs to the store. It should be inside the store. This is a type of dictionary, so it should be inside the dictionary class, but we cannot just go inside this one because, first of all, this is already defined in .NET framework. If we go inside and go to definition, you can see that right now we are inside the namespace system.collections.generic, and we have the dictionary class. This dictionary class over here that you are seeing has all the different methods that .NET framework or Microsoft has created for this specific class. But we cannot just go inside and, oh, I want to add my own, or I want to just change some things inside because this is the .NET framework. This is how it works. You cannot just go inside and then just change it. But it's so convenient. It's so convenient to just say store dot, I don't know, contains key. Because when you work with object-oriented programming, you want to call it like this. You want an object, and then you want to say dot, and then you want to say or to call the method. So store dot contains key, or I don't know, person dot get name, or something like that. So you want to use the dot notation whenever you use object-oriented programming. And this is what we want to do right now. This is not object-oriented programming per se, because we just have a method which is not really connected to the store. It just uses it as a parameter. So let's try to change that. And you can see that this is more expressive, is more declarative. Instead of like passing it as an argument, as you see here, it just passes the arguments that you actually want to make this work, but you call it on the store. So that's like the thinking behind object-oriented programming. And I'm so grateful that I'm actually teaching you guys these things, because this is not just like teaching you how to create a dictionary or how to like create a method. It teaches you how to actually think in an object-oriented way, so you don't create just functions that are separate and just rely on arguments, but you create objects with logic inside. Okay? So there are some steps, and this is the last thing that we are going to do in this series. So we need to mark the store parameter with this keyword, because this is a static method, and we are going to discuss static in the future. I'm not going to discuss it right now, but basically it means that we can call this one without initializing, because we are inside a static class. In order to make an extension method, you need to say this to the first argument, to the first parameter actually, this store, and then step number 2, make a separate static class called dictionary extension. This is what we do. We extend the dictionary class and move the dictionary or the function there. So we can create just a new class for this one. We could use Visual Studio IntelliSense, to extract this into a class. So you select the method that you want and then control dot. Control dot doesn't work. Oh, because again, this is not a static class. let's try to undo. Let me try to select it again, because I don't want to like go and create a new file. Control dot, doesn't work. Control K. I don't know why this doesn't work. Oh, because it's private. Let's try public. Public, and then select everything again. Control dot. Yes, I don't know why I cannot use this. Okay, let's create a new file. I don't know why I forgot my shortcuts. We can add a new class. So this is going to be a new class called dictionary extension, because this is what we want. We could actually name it as store extension. Store extension, but this is not like a store. Yeah, let's keep it dictionary extension, because we are trying to extend the dictionary. It's going to be public and static, because this is a class for extensions. So whenever you have extension methods, they have to be inside static. And we can go back and we can get this one out and put it here. And then don't forget the this. So step number 1, this. Step number 2, put it inside a static class. And now we can just use these or call these as we wanted previously. So store.addFruit class. So let me try to go back. Right now you can see that this doesn't exist. So let's try to say store.add, and you can see that IntelliSense has actually add fruit quantity. It has inside the IntelliSense. This is amazing, because this is our own implementation. This is our own implementation. This is not from .NET. And this is why I like it so much. And then you can just pass these arguments. So I'm going to pass these 2 arguments. Only these 2, and then not the store. And you can see right now we don't have any errors. Let me try to remove this one, because I was just explaining this and I forgot. And now it just looks as previously, contains key. Now we have add fruit quantity. And let's do the same. So right now we call the method on the object, and then we can remove the object. And this is easier to read, because it's just more object-oriented, a more object-oriented way of actually dealing with methods. You have an extension for your dictionary class, which uses or requires 2 arguments that you just pass, and you don't need to pass this as 1. This is the whole point. Notice that we do not need to pass the store as the first parameter. Indeed. And then the conclusion, I think, this is called an extension method and is a very popular way of extending the functionality of a class. As I just said, the dictionary class is already built in .NET Core. And you might use these extension methods for your own classes. Maybe you have your own specific class that you want to extend, but you don't want to actually change the functionality of that. You don't want to just create a new method inside. You just want something else outside, which could totally make sense. This is just another way of writing your code with extension methods rather than just methods inside the class. Also, I want to run the project to make sure that this works. But let's try to read this one. Refactoring. Because this function turns to be generic, we can rename it to increase value. In this way, you can use this not only for fruits, but for cars, books, anything you might create in the future. So if we go back, you can see that this is a dictionary extension. And if you remember, like a couple of minutes ago, I was trying to name it store extension. But then I thought to myself, no, I'm not going to do that. Because you can see that we have a store, and then we pass a fruit type and a quantity. If I'm going to rename this, to type and then quantity, you can see that this type is a string and this is a quantity. And it can be for cars, it can be for books, it can be for anything. This has become a generic method. And you can see that I just pointed out that you can name it increase value. So you can say F2, and this is going to rename it. So increase value, and I'm so sorry that you cannot see it, but you can actually see it here. So increase value, apply. If we go back to our program, you can see that we have an increase value extension method, which works for any dictionary of this type. So it's not just bound to fruits anymore. So we already gone to the next level of actually creating a general method, which you can use for other types of stores. If you have right now a store, var store, I don't know, new dictionary, string and double, you can have cars, for example, I don't know, Volvo, and you have like 2 of them, and you can say, instead of store, we can say car store. The point is, right now you can say car store dot and increase value. You can use this one and increase value. Now this is generic, doesn't have like fruit inside the method name, doesn't have fruit inside your parameters or your argument names. It just has increase value. Increase what? Increase my Volvo by 1. I bought a new car. So this works. This is generic, and this is the beauty of it. Let me try to remove it, and let's try to make sure that our code works. I don't want to give you guys code that doesn't work. So you can see, as before, we refactored our code. We extracted this as an extension method with this inside a static class. So these 2 things are very important to create an extension method. And then you can just use them for that specific object, and you can just see it does the exact same thing. So we refactored our code, and we have not changed our logic. So it has been a successful refactoring. Again, thank you so much for watching my video. I know this is a little bit more advanced. This is not necessarily for beginners, but I hate that. I just hate when tutorials and videos are targeted for beginners or for intermediate developers and for advanced. Like, it's just so difficult to actually differentiate between them. Like, what's the point? Like, what is the point of actually differentiating between your level of knowledge and your level of skills in this? I just want to like give a thorough journey into coding, a thorough journey into C#, and to give you the full capability to go from a beginner, so just declaring a dictionary, to actually becoming more advanced, to actually create an extension method for your dictionary. Again, if you like this video, please click the thumbs up button. It just helps me to see if you guys actually enjoyed this video and if you guys actually felt that you learned something. Again, I'm not actually I'm not sorry for making long videos, because videos like this actually help you the most, I think, because I'm able to freely express myself and I'm able to teach you all the things that come up in our code. If I'm just trying to explain this in 5 minutes, you would just get only some ideas about it, and you will not be able to get like the thorough, like the clear or the clarity that you want from the code. Because it's one thing to write code, is another thing to actually understand your code and understand why we did these things to our code. Again, thank you so much for watching, and I'll see you in the next video. Bye.